Awesome. Hey, everyone. My name is Jay. I'm one of the co-founders of Say, and I lead engineering. And today we also have Dan with us, and we're going to be dropping some alpha on Say.
Let's go.
So the best way to get started with Say is to talk about DEXs. DEXs are one of the few things in crypto that have true product market fit, whether it's AMMs like Osmosis, order book style exchanges like DYDX, or NFT marketplaces like OpenSea. The only problem is that general purpose chains hold back exchanges. First of all, there's no DEX optimizations on general purpose chains. Secondly, there's a lot of congestion issues, which is catastrophic for order book based exchanges. And they're still a tad bit too slow, even the newer ones like Aptos and Sui. And this isn't really even the fault of the layer ones. This is because DEXs are unique applications, especially order book exchanges that have really high throughput and latency requirements. So because of this, we started to build Say, which is an L1 that's optimized for trading, helping give exchanges an unfair advantage. So from the technical side, there's a few things that we've done that are very interesting. First of all, we have a native order matching engine that helps exchanges scale. Second, we've added in a new consensus layer called Twin Turbo Consensus, which helps improve latency and throughput. And lastly, we've made use of market-based parallelization. So we're currently the only Cosmos chain that is making use of parallelization. So today, I'm going to be telling a story about Twin Turbo Consensus. When we originally got started with Say, we got most of the chain built out, and then we wanted to see how we can become faster. So basically have higher throughput, lower latency, and figure out how we can help exchanges scale. So we started off with baseline Cosmos metrics. Then afterwards, we chatted with Zaki, chatted with Marco, and we got ideas for how we can change the Tendermint configurations to get better performance. So we did that. We got up to 7,400 orders per second, and then we started looking into what we can do next. So then we looked into how the end block is processed. We realized that it's CPU bound, and then we added in parallelization, which got us up to 12,000 orders per second. What we looked into afterwards was more of the actual consensus layer, how blocks are propagated and how blocks are processed. And that is called Twin Turbo Consensus. So it's made up of two things. The first thing is intelligent block propagation, and the second thing is optimistic block processing. So I'll start off by talking about intelligent block propagation. So let's say, for example, I am a block proposer, and Dan is a validator. So I'm going to be proposing a block, and Dan is going to be voting on it. Both of us have our own local mempools, and in this diagram over here, I mean, the main difference is that both of us have transactions A through F, and then I have G and he has H. And that's just because different validators will be receiving different transactions based off the network topology. So sometimes it might take a little bit longer for certain transactions to make it to a validator. So I'm the block proposer. I create a block. In this case, I create a block that has transactions A through E inside of it. Right? Pretty straightforward so far. The way that Tendermint normally works afterwards is I will create a block proposal. So this is going to be one message that has the block ID inside of it, which is a hash of the entire block. I will then send that block proposal to Dan. I will also take the block itself, break it up into chunks, and then send that over to Dan as well. So what does Dan experience? Well, Dan is waiting, then he receives the block proposal, he waits some more, then he receives the first chunk, then he waits some more, and then he receives the second chunk. So from Dan's standpoint, he's spending a lot of time waiting to receive these chunks, and the content of these chunks is content that Dan already has in his mempool, right? Transactions A through E are what are getting sent, and Dan already has transactions A through E, which if you think about it is extremely wasteful. Like he's just waiting even though he already has this data. And we did we looked into how this is working in our internal testnet, and we actually found that 99.99% of the time, validators have every single transaction that is being proposed in the block. That's crazy, right? That means almost every single transaction is already there with each validator, except they're still waiting to get every single transaction sent over as part of this block propagation layer. So we thought we could do better than that. We thought this was very inefficient, and that's what intelligent block propagation is. So the solution that we came up with is to change the block proposal. So if you look at the diagram, on the left-hand side is what's happening with normal Tendermint. On the right-hand side is what we're doing with intelligent block propagation. Right? So if you look closely, the main difference is that we have hashes of transactions A through E included in the block proposal. Well, how does this change anything, and how does this process work now? So the first part of it stays the exact same. We still have the block proposer, which is me, creating a block by looking at transactions in my mempool. But then the second part is a lot more interesting. So in the happy path, I'm going to be sending a block proposal that has hashes of transactions A3 over to Dan. And Dan already has transactions A3 in his mempool. So what he can do is he can look at his mempool, he sees transactions A3, and he can construct the block locally, rather than having to wait for the network latency to be receiving all of these block chunks. So this is the happy path. It greatly improves throughput. What about the unhappy path? So in the 0.01%, sorry, not 0.001, in the remaining percentage of the time, Dan will fall back to using the same mechanism that was previously being used. So what that means is I, as the block proposer, will send out a block proposal that has the transaction hashes, and I will also include the block ID over there. And then I will continue to take the block, break it up into chunks, and then send those out over the network. So in the unhappy path, Dan will just be using the same exact mechanism as normal Tendermint, and in the happy path, he'll be benefiting a lot from throughput. So this is a lot faster. We observed that this actually led to a 40% improvement in throughput, which is massive because we've already made all the low-hanging optimizations that could be made. So this was a massive win for Say. So before I continue, can you guys just raise your hand if you understood what I was saying around intelligent block propagation? Awesome. I'm actually seeing a lot of hands, so I'm pretty happy about that. But if anyone has any questions, I'll be at the Say booth after this talk. So if anyone wants to talk about block propagation, I'm your guy. Okay, the second thing that we did is optimistic block proposals, or optimistic block processing. So this is actually a lot simpler for concept. What happens right now with Tendermint is that as a block proposer, I'll send a block to Dan, then Dan will run some sanity checks on it, and then he'll just hold on to the block, and then he'll vote on the block through pre-vote and pre-commit, and then he'll actually start processing the block. So what this means is he's actually holding on to the block, but not doing anything with it during the length of pre-vote and pre-commit, which is bad, right? And it kind of makes sense because you don't know if the block is actually going to get accepted or not. If you're thinking there's going to be very adverse Byzantine nodes in the network, then it's better to not do anything. But what we've noticed is that most of the time, the first block is the one that ends up getting processed. Like the first block is the one that everyone votes on, and then it ends up getting processed anyway. So because of that, we realized it makes more sense to be optimistic. So what optimistic block processing is we will take the first block at any given height, and as soon as the validator receives it and runs sanity checks on it, they will then start processing the block in parallel with pre-vote and pre-commit. So if you look at the diagram, pre-vote, pre-commit are happening, and at the same time, we're doing block processing. So through this, we're able to have the block get processed faster, we're able to update state faster, and the overall latency goes down. So this is the happy path, right? What happens if there's a Byzantine node or validator makes a mistake, and then you're not able to optimistically process? So what's actually happening under the hood is that we are taking whatever the proposal is, we're updating a candidate state. If it's successful, then we'll commit that state. If it's unsuccessful, then we'll discard that state. And then we'll move on to the next round, and then from the next round onwards for any given height, we'll just be processing it the normal way where it gets processed after pre-commit. So through this, we observed nearly a 33% improvement in throughput as well, which is massive for Say. So overall, through Twin Turbo Consensus, we've been able to get up to 22,000 orders per second that we're processing, largely using core Tendermint. And we're also able to get around 450 millisecond block times. So if anyone wants to chat about this, I'll be at the booth afterwards. I'm happy to go more in depth on this. And I'll now pass it over to Dan to talk more about Say ecosystem.
Oh yeah, thanks Jay. And big props to you and leading up the engineering team, configuring Tendermint to getting to sub-half-second block times and 22,000 orders per second. That's insane. It's the fastest Cosmos SDK chain ever, and it's helping us to execute our vision. So at the beginning of this year, we had this vision of building the core infrastructure for decentralized exchanges and trading applications to be able to succeed on chain. And when it went from this vision at the beginning of this year to then building out the team, and now we're a team of 18 full-time, and we've built the Say chain, and it's live, and we're on incentivized testnet, the Tsunami incentivized testnet. So we launched that in July, and it's been a wild ride ever since. So we're seeing incredibly fast block times, and we've seen a lot of participation. So there's over 2,000 validators to date that are currently validating the Tsunami testnet chain. And we open it up to developers, to crypto enthusiasts, to the greater Cosmos ecosystem, to validators to get involved. And there's over 25,000 active members that are participating in the Tsunami testnet. And people are helping us with stress testing the chain, identifying bugs, and also trying out protocols that are deploying on Sei. So if you guys haven't tried it yet, Vortex is a perpetuals protocol that is live on the Tsunami testnet now. So if you want to get your hands dirty and start trading and using leverage on Sei, you can use Vortex. And on the Tsunami testnet chain, we've had over 200,000 transactions in the last 2 months, and a lot of them are IBC transactions, so it's an IBC-enabled chain. So we've had a lot of traction on testnet, but personally what I find the most interesting and what I think is the most exciting is really the validation we've had across the ecosystem. So there have been 50 teams coming from Near, Solana, Terra, and also Polkadot that have committed DeFi teams to building their DeFi protocols and deploying them on Sei as we gear up towards mainnet. It's been pretty crazy, and to see our development team kind of bring these on, and I think that that's a testament to the engineering team and what they built with the Sei chain, but also a testament to IBC and the stickiness of what we're building with the Cosmos SDK and IBC. Just to name a few, UXD is a delta neutral stablecoin that came from Solana. It's a multi-coin chain backed team. White Whale, they're a Cosmos SDK chain that is doing price efficiency and capital efficiency on top of Sei. Synther is a synthetics protocol. And then Axelar is, an awesome bridge and providing greater access to blockchains outside of the Cosmos SDK, Cosmos IBC chains. And then we're also working with some of the top wallets, including Leap and Kepler. So yeah, we're really excited, and over the coming months, there'll be many more teams that will be announced building on Sei as the Sei DeFi and trading ecosystem continues to grow. But one team that I'm really excited about is Nitro. So Nitro is the first ever Solana virtual machine that is broadening the Solana developer ecosystem to come to Cosmos. So it's the first ever C-level VM, SVM, as an optimistic rollup on top of Sei, so that Solana developer community can deploy their applications natively within building on Rust and the C-level consensus, and deploying them natively on Sei and getting access to the broader Cosmos IBC. So we've seen that Ethereum has a very robust developer community, and Solana also does as well. And a lot of the developer teams are really excited about Sei and want to build on a better chain, but are more comfortable in Solana. So we're seeing a lot of these teams also get excited about Nitro and coming and deploying within IBC. So it's a really powerful execution environment, and I think it's another step in broadening the scope of what we're able to do with Cosmos and bringing more developers to the Cosmos. And we've had a lot of traction so far as well. We've been excited. We've raised some capital. We've had some really great backers, including Multicoin Capital, Coinbase Ventures, Delphi Digital, Hypersphere. All of them are here. And a lot of institutional backers, especially market makers. We see that the industry, especially within DeFi, is continuing to evolve, and institutions are getting involved. And so as we're building out the core infrastructure for DeFi applications, we want to make it easy for teams that are coming to Sei to be able to get liquidity and have institutional market making. And with that, today is an exciting day. We are announcing right now a $50 million Sei ecosystem and liquidity fund that just went live today. There's a TechCrunch article that just went out about it. I'm really stoked. And as the developer community continues to grow, and as more people are finding great opportunities to build DEXs, to build synthetic protocols, to build derivatives, to build DeFi primitives, and you're excited about building and launching on Sei and growing out within Cosmos IBC, there's opportunities for you. So we've had really good backers that are supporting us on this, and I'm really excited to see kind of what the next wave of DeFi founders are looking like. And if you're looking to build a killer app, come talk to us at the booth, and you can apply now live. Our Twitter account, Sei Network. We just posted about the ecosystem fund, and the application is live as of right now. So we're excited about all we're building, and we're excited about the growth of IBC. I was at Cosmoverse just last November, and less than a year later, it's incredible to see this burgeoning ecosystem. And I think we're at 50 plus IBC-enabled chains now. And a year from now, I'm expecting it to be 200 plus. So yeah, I'm stoked about all we're building, and yeah, excited for all that we have ahead. Come find us at the booth if you have any questions.
Awesome. Thank you, everyone.
Cheers.